A very good morning, students. Let us look into a next topic called de-multiplexer. Let us design 1/4 de-multiplexer. Before getting into the design, let us understand what is a de-multiplexer, and then we will design 1/4 de-multiplexer. A demultiplexer is also called as demux, or we can call it as one-to-many device. What do you mean by a demultiplexer? So this is a device that is used to take a single input. This device takes single input and forward that input to several outputs. I repeat, demultiplexer is a device which takes single input and forward it to any one of the several outputs. It can forward the input to D0 or D1 or D2 or D3, but it can forward only to one of the several outputs. This is done with help of select lines. The select lines will decide to which output the input has to be forwarded. For example, let us see here. There are 4 output devices which is connected to a single input. Input is coming from a computer. Demux will decide to which device, select lines will decide to which device, output device, the input has to be connected. Are we going to connect input to laser printer or fax machine or inkjet printer or pen plotter? This is decided by the select lines. So number of select lines required for the demultiplexer is based on a formula. The number of select lines is given by 2 power m is equal to n, whereas m is the number of select lines, n is the number of outputs. So in this example, if you see here, there is a single input and 4 outputs. So you call it as 1/4 demultiplexer. Let us design this 1/4 demultiplexer. This is the block diagram for 1/4 demultiplexer, which has single input. Then variable name assigned for input is I, and there are 4 outputs, which is Y0, Y1, Y2 and Y3. The number of select lines required for selecting to forward the input to the output or one of the output is decided by number of select lines. This is given by a formula. So 2 power m is equal to n, where m is number of select lines, n is number of outputs. In this case, number of outputs is 4. 1, 2, 3, 4. So 2 power m is equal to 4. 2 power m is equal to 2 power 2, which is nothing but 4. So value of m is equal to 2. So m is nothing but number of select lines. So we need to have how many select lines? 2 select lines. So there are 2 select lines, S0 and S1. So let us start designing a demultiplexer. After obtaining the block diagram of demultiplexer, we need to draw the truth table. So number of select lines are S0 and S1, S0 and S1. Number of outputs here is Y0, Y1, Y2, Y3. So Y0, Y1, Y2, Y3. So whenever we know demultiplexer is a device that takes single input and forward it to one of the several outputs. So here when S0 and S1 are the 2 bits that decides to which output line the input has to be forwarded. So since there are 2 select lines, 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. If S0 and S1 are 0, 0, it is going to forward the single input to Y0. That is the reason. Can you see here? Y0 will be I. I is nothing but the input is forwarded to Y0. I. Rest is all zeros. When S0 and S1 are 0, 1, next it is going to forward 0, 1. I will be forwarded to Y1. So Y1 will be I. Rest is all zeros. When S0 and S1 are 1, 0, the input I, single input I, will be forwarded to Y2. So Y2 will be I, rest is all zeros. When S0 and S1 are 1, 1, the input I will be forwarded to Y3. So input I is forwarded to Y3, rest is all 1. This is very clear that at any point of time, the input is forwarded to any one of the output. That is, that output is decided by the select lines. Now let us derive the logical expression for the outputs y0, y1, y2, y3. After completing this truth table, let us write the logical expression. We will start with y0. Y0, if you see, for which case y0 is I? It is for S0 bar, S1 bar. So y0 is S0 bar, S1 bar. Clear? For which case y1 is I? It is for S1 bar S0. S1 bar S0. For which case y2 is I? It is for S1 S0. So it is for S1 S0 bar. For which case y3 is I? It is for S1 S2. Sorry, S0, S1, S0. Now what I'm going to do, for this case, I'm going to draw my outputs. For my I, you need to understand, output will get what? The input I only when you can see from y0. What is y0? S1 bar, S0 bar. When S1, these are the three inputs. Input I, S1 and S0. When S1 and S0 are 0, 0, S1 bar, S0 bar. Can you see? S1 is connected to a NOT gate. There is a bubble here. There is a bubble here. So S1 is connected to NOT gate. Output will be S1 bar. Here the output S0 is connected to NOT gate. Here the output is S0 bar. Then S0 bar, S1 bar is connected with 0, 0. Then input I will go to which output? Will go to y0. So next case, y1. y1 is S1 bar, S0. S1 is here, S1 bar, and S0. What is going to come? I is going to come. You can write I here if you want. So I is the input. It will be forwarded to that particular gate when S1 bar and S0 bar for y0, S1 bar S0 for y1, S1 S0 bar for y2, and S1 S0 for y3. Clear? So this is how we design a demultiplexer where the input is forwarded to any one of the output based on the select lines S0 and S1. Thank you.